day before, on Monday, and that's why I sent an email to everybody and say, okay, I have to cancel class because I really cannot do it. All right, so we'll go ahead and get back to our little project. So I'm hoping you guys are kind of shadowing me in terms of your H2O project. Are you guys doing something similar to what I've been doing in class? Because that's kind of what you need to do is to shadow the approach with your H2O project. You definitely have a different type of model, but the approach would be the same or similar in terms of where how to design your classes and how to design your interfaces. So I'll just go ahead and get started with the project and continue to work on it. As soon as I'm done with my rock, paper, scissors project, your project will be officially assigned at that point, and you won't get a whole lot of time, maybe a week or two at that point to finish the project, because I'm expecting everybody to be shadowing my progress with this project here. And given that this is running out of a USB 2.0 connection to an external hard drive, I don't think it's slow at all. I mean, that's a pretty respectable speed. All right, so here's our rock, paper, scissors project, and you can see that get is working because it's saying this is RPS master, which is a branch in get, the revision control software. So it's really quite handy. All right, so we will look at the source code. We have quite a few things done already. Last time we tested the model using using a single button to inject to start up the model and do certain things. I commented on the random number thing and basically say, well, that may not be the easiest thing or the best thing to do when you are just testing your program. So when you're just testing it, using a random number sequence that is repeatable or deterministic may be a better way to do it, because otherwise, you don't know what the program is supposed to do next. All right. All right, so let's take a look at all the classes and interfaces that we have designed up to this point. Choices is not really a class. All it is to classify or to list all the options for your choices, for this particular game. In your case, okay, if you want to, you can also store the state of water molecules using a enum type. So in your case, it'll be ice, water, and steam. Okay, so that way, you don't have to define integers, and then you can also, use that to represent the state of the model. There are several ways to do it, but that's definitely one way to do it. And then we have machine state. This is what your states should be listed as. So in this particular case, in terms of playing the rock, paper, scissors game, there are 5 states in the diagram. There's the initial state, the final state. Those 2 states really should be there regardless of what kind of state machine you're designing. We have the no winner state, which means I don't know who's winning this particular game yet. So it can be the initial state where we are just starting up the game, or we go through a few rounds and both the computer and the user always end up choosing the same choices. So it's a draw for every single game. We have app winning, and we have the user winning. So those 2 states are basically reflecting, okay, one of the player is winning and which one is winning in those cases. The model itself is in RPS model. So when you look at RPS model, it is it's an entire, it has all the logic. The most complicated one is user choose at this point, which is responding to a user interaction part, and basically say, okay, what if the user is choosing a particular choice, and then based on that choice, I use a switch statement so that when the user chooses rock, I would look at what the app has chosen, and if the app also chooses rock, then the quote-unquote new state is also no winner, because in that case they have chosen the same choice. If the app chooses paper and the user has chosen rock, then the app is winning. If the user chooses rock and the app chooses scissors, then the user wins. So I'm using one switch statement per choice for the end user. Your particular program is going to be a little bit easier in a way and a little bit harder in a way, because you'll be dealing with temperature change instead of a choice from the end user. So you have to compare the temperature to the thresholds of freezing and also the threshold of boiling to determine what would be the new state of the water molecules. I also define a subroutine called notify listener adapter, and that's a pretty easy little subroutine here. Its only purpose is to isolate the rest of the program from the fact that I may not even have a listener adapter assigned to this particular model. In other words, I may be testing it in a way using just a debugger, and I don't need a listener adapter to be talking to it. In other words, I'll be interacting directly with the model, which I have done in the previous class. Are there any questions at this point? No questions? Okay. We also talked about the assert statement. So for those of you who might have forgotten, the assert statement looks like this. There are two forms to use the assert statement. One simply states a condition that really should be true at this point of the entire of this program. The other form, asserts a condition, and it also has a value to report in case the condition is not met. Okay, this one will only say that on line 88, this condition is not met, which is already giving you quite a bit of information. If you are writing actual commercial applications, you should throw in assert statements, especially at the critical points. By a particular point in your subroutine, if you know that a particular state or condition should be true, make an assert statement. So this way your application has a chance of catching itself before it gets too far, before a problem gets too far. Are there any questions about the use of an assert statement? You do not have to do it in your H2O project, but it is a good practice for any type of application development. Most programming languages support assert in one way or another. Some are more native, like in Java it is very native. In C++ it's not as native, but it is still supported. Yes, go ahead.
Why would you use assert? Why would you just use an if statement?
Because assert also throws an exception when the assertion condition is false. And it is a statement in Java, which also means you can probably set up the compiler to compile differently depending on how you want the assertions to be done. You can basically say, okay, ignore all the assertions and do not give me any exceptions. But it is kind of equivalent to a conditional statement with a throw inside. Right. So that's the RPS model class. We have play again. In play again, right now it only has an assertion, and it changes to a new state because when we click play again, it is in one of the two states where either the application is winning or the user is winning. And I have an assertion to make sure that I cannot click play again or trigger that particular event unless I have either the application winning or the user winning at that time. Back button pressed, I change the state to the final state of the state machine, and I give my listener adapter one last chance to say, okay, the model is about to die. Okay, what are you going to do? Okay, so that gives the display or the view a chance to clean up and basically say, okay, thank you for playing this game with me, blah blah blah. The application is about to exit. And the last one is basically a utility method. It allows the model to remember who its listener adapter is. In other words, who's my broker? If I need to let someone know about my state change, who am I going to notify first so that that broker can let every other party know about my state change? So that's what the set listener adapter is about. Are there any questions about this little quick recap of RPS model as a class? Okay. No questions? If there are no questions about RPS model as a class, we'll just kind of continue to talk about RPS model as an interface. I define this as an interface, so that as far as an adapter is concerned, it does not need its own private field to be of a subclass of RPS model. It can be anything that fits this particular model. In other words, I'm removing a inheritance restriction based on class, and when I go through an interface to specify the type of something, that makes it possible so that RPS model or whatever that a listener adapter is connected to can be anything that implements this particular interface. It does not have to be a subclass of RPS model. Are there any questions about this part? Because I think this is really one of the parts where it is kind of important, because we want to understand why we use an interface when a class would do in a smaller program. It has to do with the fact that maybe later on you don't want to use this particular RPS model class, and you want to use another class that has an entirely different inheritance hierarchy, and use it to implement IRPS model, and that this makes it possible. Anything that implements IRSP model can be used as a part of the listener adapter. Okay. Any questions at this point? No questions? Okay. I think we stopped pretty much here. We stopped implementing the program at this point, which is the interface of iListener adapter. This is the interface that is the type of a listener adapter inside the RPS model. So if you go back to RPS model and you go all the way up, the listener adapter is of the type of iListener adapter, which is an interface. All right. Are we still doing okay so far with this structure of this program? Okay. So what we'll do next is we are going to finish up the listener adapter class that implements iListener adapter as an interface, and then we'll continue to talk about the view, and at this point the view is going to be the main activity class, but we'll also have a view interface, as a type that the rest of the world knows about, and that's what we'll do next. All right, so we'll go ahead and let's go ahead and fix this warning sign here. The warning sign has to do with user win counter, user lose counter, and also the game counter are not used anywhere. The counters are incremented and decremented accordingly. So you can see that the counter is incremented over here, and the counter is incremented over here, and this counter is incremented over here. They are all initialized in the initialize subroutine or method, but they are not used by anyone else. In other words, nobody else seems to care about user win counter, user lose counter, and also game counter. But that's okay. We'll deal with that later. At this point, we are not too focused on getting all of these little things done. We want to structure the program right first, and then we come back and then handle the little details. All right. So we'll go ahead and implement a class that implements iListener adapter. So we'll go ahead and say new. In this case, it will be a new class. And the name of the new class is going to be listener adapter. Now this is really kind of like a generic name of a listener adapter. So if you want to do something to make it specific, you can say it's a simple listener adapter where you can only connect a model to a single view. Because no one says you can only have one view corresponding to one model. Well, this particular one has a limitation. I'm not going to use a list or an array to keep track of multiple views corresponding to the same model. I'm just going to use one single view to deal with one single model. So that's why it's a simple listener adapter. You can say one-to-one. There are many ways to name this particular one, but simple is okay. And add this new class. Choose interface. Implemented interfaces section. So it would be listener adapter. Click finish. And there we have it. So this time, I created the class letting the tool know about what it's for, and it automatically, included everything, including implements iListener adapter in the class definition, as well as override state change machine state S. Okay. So are there any questions about this step here? A listener adapter needs one private field to keep track of, okay, but who are the views that I'm supposed to keep track of? And I cannot define that yet because I don't have an interface of the view defined yet. Right, so it's time to define that also. So go back to here, this time we're going to define an interface. And as the name of an interface, we'll start with the uppercase I letter. And this time it will be basically just a view. This is the interface of a particular view. And we'll finish here. It's an interface. We'll just leave it the way it is, at this point. We'll keep adding more stuff, as we need to. So now we go back to simple listener adapter. And now we can say, okay, I need a private member which is of the type iView. And in this case, iView is just going to be a view, a single view that this listener adapter is connected to. We're still doing okay so far with this program. Okay. Now, how do I set this view? Because a view has to register with a listener adapter first, so that the listener adapter knows, okay, so I guess you are responsible to reflect changes to this particular object. That means we need a register method with this listener adapter. But it is also something that we want everybody to use, when we are dealing with a listener adapter. So that means it belongs to the interface definition also. So here we go back to the listener adapter interface and add to it a new method, which is public void register view. And in this method, the only parameter is going to be of the type iView, which is an interface type. And we want to specify just v here, and that will be a new method. Now we can go back to simple listener adapter, and right click, and add unimplemented methods. This is really kind of handy because now it also it can basically look at the changes that I made to the interface and make the update the overridden functions accordingly. It's a really nifty feature because now I don't have to duplicate all that typing over here. So register view in this case is really simple. All I have to do is to say my private instance member view is going to be just v, the parameter itself. That's all I need to do. Are we still doing okay at this point? Now, this is why it is called a simple listener adapter, because it can only handle one view at a time. Instead of using an array of views, I only have one single view, and that's why I call this simple listener adapter instead of complex or array-based listener adapter. Are there any questions about why I call this one simple? Because what I could have done is to make this view here, instead of calling it view, I could call it views and then turn it into an array. But I did not. I just want to keep this simple at this point. Any questions? Did you guys remember why there might be different views or why that might be useful? Because one view can be just a log file. Okay, it can represent a log file. So every time there's a state change, it does not actually show anything on the screen. It does not report anything to the website. It just creates a file. It appends an entry to a text file and say, at this time, there's a state change from this state to this state. That's all it's going to do, is to keep all the information in a log file. And then later on, you can retrieve the log file and find out what happened to the program. Okay. So that's why you can have many views corresponding to the same model. Now, what view can interact with your model? In other words, what views can actually inject events or triggers into your model, your state machine? That's a whole different story, because you may or may not want to have multiple views being able to interact with your model. But as far as just being a bystander observing your model, there's no reason why you cannot allow multiple views to do it at the same time. In this case, I'm placing this really rather severe restriction here and say you can only have one view associated with this adapter. All right. So now with view already implemented here, I kind of know what to do with state change. Because what I want to do with state change is to tell the view and say, hey, you know what? The model has a state change. You need to update the screen accordingly, depending on your logic. Do whatever you need to do, but I'm just telling you that the state machine now has a state change. So that means, view, as I view, the interface here, I need to give it some public methods inside this interface. So I would go to, I would say public void state change. And as the type of the state change, I'm going to use machine state S, which is the current state, the state that we're transitioning into. So now, iView has a particular method, and then I can go back to simple listener adapter and just make use of that. Now, before I make use of that, I can, if I want to, make a comparison first and say if view does not equal to null, which means it is actually initialized to something. Only in that case, go to view and invoke its state change method and change that state to S, which is passed to me by the model. Is that okay? So in this case, it's a really simple relay, because I'm just saying, okay, if I do have a view associated with me being a listener adapter, I would just go ahead and notify one single view about the state change. But if I have an array, then this logic is a little bit longer, because I need to go through a loop to make sure that every element in the array, and each one is an iView reference, and I want to notify each view and say, hey, there's a state change, hey, there's a state change, hey, there's a state change, so that all of the views will get updated at the same time. But this is a simple one. I just have one single view, if any, to handle, and this is how I'm going to handle it. Any questions about this code at this point? No questions? Okay. If there are no questions, now it's time to go back to main activity, which is our view class. So what we want to do is to say this extends activity, which is fine, okay, but we also want this to implement iView because it is a view. Implements iView. There we go. And it complains because we are lacking the unimplemented methods. So we'll just go make it add unimplemented methods and scroll to the bottom part here, and now it has a method called state change, a machine state. Okay. Now when we first start with this one, maybe we should just be a little bit modest and say, well, maybe we'll just make it very simple and not do anything too complex. Maybe we just show on the screen a message corresponding to the current state. So that's exactly what we're going to do here. And the quick and easy way to do it is to use a switch statement. So I'm going to switch the state as here and say case machine state doesn't give me the enumerated type or the enumerated values. Okay, initial state, final state, no winner, app wins, and user wins. So let's go back to main activity. The qualified case label must be replaced with the unqualified enum constant no winner. All right, there we go. The next one is initial state. Initial state.
Yep, double I in there.
But if it's a
Check your
double I,
enum. Check your enumeration.
I think it's in the enum. Yeah. Yep, sure enough. Double I. Back to main activity.
Can you back up a little bit for 1 second? This state change in this class, main activity class, it's implementing this method that's part of the view interface, or
The iView, yeah, iView is an interface.
and why? Wait. Do you mind going up toward the top of this? The top of this. So you added it as an implements
iView,
iView.
right.
Okay.
Final state, user wins, and app wins. All right. So for each one, I can now specify, a message to, display, and I'll just be a little bit lazy here, and use our text view for that purpose. So the text view, let's see, we can retrieve it by this kind of syntax. Text view, find view by ID. And that'll be our text view 1. And then we want to say set text. All 1, 2, 1, 2. All right. Here we go. I didn't import the class first, so it doesn't know what to do with it. Now it does. So we want to set the text field to something that reflects no winner. Technically speaking, I should not use a literal string here, because whenever I use a literal string, double quote, something and double quote, means it would be difficult to translate this application to another language. In other words, technically speaking, I should use the string resource and put all the strings into one single place. Okay, but so this, if I do it this way, it's not really the best way to do it. But just to test it, okay, I can kind of do it like this, even though it's not really the best way to do it.
How would you accomplish that if you're generating the text real time? How would you accomplish that if you're generating text real time?
That's a good question. It depends on whether you can leave empty slots, in a sentence. So if the grammar of the language or whatever sentence you're generating is similar enough of all the languages that you want to implement, then it will still be okay, because you still have, like, let's say you want to report the user has won, X many times, okay? So if all the languages that you want to use, in this case it's easy because there's only one unknown. So you just have a prefix portion of the sentence, the number, and the suffix portion of the sentence. So for that one sentence that you want to spell out, the user has won, this many times, you will have to specify two different pieces with the number stuck in between.
And what if you have like a name?
Like a name?
Yeah, because if you want to avoid using quotes and to use it in a resource.
Right.
Can you put it in a resource and use it there, or just have like an empty resource, or add to the resources?
You would do it inside the string resource. So in this case, we would go to down here. When we go to resources, it's under values, under strings.
Yeah.
So you can basically add a new string here as a resource
During code run?
during.
During the running of the application?
No, you cannot add to the string resource during when the program is running.
Okay.
Yep. But the template should be here. So in this case, if you want to report the winner has won so many times, you can say the winner has won space. So that will be the prefix of that sentence.
Yeah.
Many times, is also going to be the suffix of the same sentence. So that means, when you want to translate that sentence into a different language, whoever doing the translation just has to specify which part comes before the number and which part comes after the number, regardless of the language being translated to. But for the time being, I'm not going to spend too much time to deal with this because it is not the focus of this discussion. So I'm just going to do it the kind of lazy way and just use literal strings. Because what I want to do is just to demonstrate what the listener adapter is going to accomplish. So this is no winner, and this is the initial state. And final state. User wins. And app wins. Now, if you're paranoid about things, you can also add one more thing here. You can say default and basically assert Okay, here's the question. What do you assert when you're not supposed to get here to begin with?
If a machine state was passed, that's not part.
Well, but this has to be an expression.
Initial state.
Oh,
That's always true, I guess.
Yep. You just say assert true. Because you really should not be here in any case. So so when you get to this point, you'll get to the default case, something is wrong. And you should make this condition always true. What is the expression that is always true? Well, I can name a few. Okay, 1 equals 1 is always true, 2 equals 2 is always true. But what about just true itself? Well, that's always true too. Is that making any sense? Now, when the assertion happens, it does report the line number, so it will be useful because it will report on line 61 of main activity. This assertion has asserted. Actually, I take it back because when the assertion is true, it's okay. You have to say when it's false, then it is not okay. I take it back because it's asserting something is being true is good. So if whatever you're trying to assert is false, that's what is going to cause an exception to happen. So I take it back. It has to be assert false here. All right. So I think we are almost done here. And instead of writing everything from scratch, I'm going to go back to test model and reuse test model at least one more time. So this time, go ahead.
Would you mind going back to what string do you display for initial state and final state? The winner or initial state?
Say again?
For the state change in the
Right.
main activity.
Yeah.
So for the initial state and the final state,
Mm-hmm.
what are the strings? Oh, you just display initial state and final state.
Yeah, I just displayed the name of the enum itself, but in lowercase. Yep. It's not intended to be informative. It's really just for showing display purposes, just so that we know we can display that we reflect the state accordingly. All right, so that's almost done. Now we can go back to test model, which is our little subroutine to basically get everything done. There are several things to do because in addition to a model, now we have to create a view adapter. So now we can say, okay, I want to create a simple listener adapter, and we just call that LA for listener adapter. LA is a new simple listener adapter. But this is not going to do us any good because if I just create a simple listener adapter object, at this point, the only thing referring to it is my local variable LA. And this local variable is local to the method itself, so as soon as the method is done invoking, it goes away. If the only reference to the object is gone, then the object is going to be deallocated in the next garbage collection cycle. So I have to do something about it before I get out of this subroutine. There are two things to do about it. The first thing I need to do about it is in the model itself, the model has to register that particular listener adapter. And I cannot remember whether the model already has a method to do it. So let's go to IRPS model. And it does have set listener adapter, so that's what I'm going to use to do that. Wrong window. Set listener. Okay, it's complaining about that. Add argument to match. Oh, it is smart. Did you guys see what happened? No? Okay, let me do that again. All right, so I know which method I need to call. I need to invoke. It says, hey, but this method requires an argument. So when I click it, okay, when you look at the hover, I have these options. Add argument to match set listener adapter, and the type is listener adapter. In other words, it is intelligent enough to find out, okay, one, set listener adapter is a method that requires a parameter, or at least one of the signature requires an argument. The type of the argument is listener adapter, which is an interface. And if I click the first option of add argument to match set listener adapter, it will locate LA, which is of the type class simple listener adapter that implements interface listener adapter. It figures out all of these things and say, okay, this is the only choice that makes sense here. I'm going to pick it for you. Okay? So if I click this option, it just adds LA right there, and that is the right choice. It really is just the right choice. Okay? Yep.
So when you want to set the listener adapter after you have done that?
Yeah.
Okay.
That's why it complains about it too. So when you look at this one, initialize variable first. Okay. I don't know how many people have any experience with writing compilers and development tools. I used to be in that business, and I can tell you what Eclipse is doing is actually quite impressive. I mean, it takes a lot of logic and code and inference engine in order to do what it's doing. Making all those suggestions, and some of those suggestions are exactly what I want. I mean, that's actually pretty impressive.
Still, wouldn't you want to do it after initialize? In case initialize the internal listener adapter variable to null?
No, it's already null to begin with. Initialize does not do that, if I remember correctly.
Let's see.
So let's go take a look at. Oh, okay, because I changed the name here. So I changed to initial state. We want to look at initialize, right? Initialize does not change that to null.
Listener adapter.
Yeah, it does say notify listener adapter. That means if I set the listener adapter first, this would be helpful, right? Okay, so let me save all the files, make sure all the errors are gone, and go back to where was I before? Oh, in main activity.
But would you normally initialize the listener adapter to null inside the RPS model?
Say again?
Normally, I would think a method such as initialize, you would normally initialize all the internal.
No, you would do it inside the constructor.
Inside the constructor.
Inside the constructor.
Okay.
Because when you first create the model object, that is when you want to do all the initialization. References are by default initialized to null already. So this is not like in C and C++. When you do this in C++, a pointer is not initialized to anything when you start off. When you first allocate a storage for a particular object in C++, if you have a pointer inside the object, those are completely uninitialized. So in C++, you should initialize all the references. But in Java, it is different because the references are by default initialized to a value of null, and as a result, you don't have to do it. I mean, you can do it. It just doesn't do anything extra to what Java is already doing. Yep. All right. So now, with this subroutine call, with this method here, the model knows, who is its broker when it comes to talking to the listeners. But we have one more thing that needs to happen here, is the listener adapter itself also needs to know, okay, if the model tells me there's a state change, who am I going to relay that message to? So that's why, we have one extra thing to do, and this time it has to do with LA itself, and we have to set register view to, what should we do? Well, let's look at the suggestions. add argument to match register view iView. What do you think is going to happen when I click that link here? What is going to match it? You look at all the local variables here. We have M being a model. We have L1 or LA being a simple listener adapter. Nothing seems to match the type of interface iView. There's a hidden variable inside any method that is instance-based. What is the name of that hidden local, well, we can call it a variable, we can also call it an argument. You can look at it either way. Come on. This, yep, this is the right one. This is the right one. So let's see if it figures it out automatically. Oh no, you got it wrong. That would do it. I'm really a little bit disappointed here. It's because I was hoping that it would be intelligent enough to find out that this pointer is of the type that will match in this slot. Well, didn't quite figure that out. Okay, so I guess there are limitations. All right, so this time, it will behave differently. As far as the program is concerned, you would not be able to actually see the state changes because it's going to be so fast. It's like that, because I'm not allowing any time in between. But let's go ahead and let it run anyway, just so that we have an idea of what it looks like, or at least we can find out what is the final state, after everything is done at that point. So we'll go ahead and test it with my smaller device here. And by the way, I just bought a, what's the name of the thing? Oh, a Fitbit. Okay, a Fitbit is a wristband device. It's nothing more than a fancy accelerometer that is wearable. It has its own little vibration motor in it, so it can also notify you of something, like wake you up in the morning. But its purpose is to track your activity, your sleep activity or your sleep pattern, and also how active you are during the day, and so on and so forth. But the reason I mention that is because the Android app for that particular device will only run in Android 4.3 or later. In other words, if you have an earlier version of Android on any device, it's not going to run. It needs Android 4.3 or later, which is pretty recent because right now I think the current version is 4.4.2. So 4.3 is pretty recent. Not a whole lot of devices are running 4.3 at this point. The reason why it needs that is because Android just added an interface to low power Bluetooth communication as of version 4.3. And this app makes use of that API. Okay, I just want to bring this up, because I want to kind of show you, what can prompt Android to get updated, and why sometimes you will have to kind of give up backward compatibility to make use of a later feature. Because for this particular device, if you do not enable low power Bluetooth communication, it can drain the battery of your Android device just like that. Okay, in an hour or so, you're done. I mean, you have no power left. So that's why in certain cases, for certain types of apps, it makes sense to trade off and say, okay, we can sacrifice not being able to support earlier devices, but we do want this to work properly, and so we want to make sure that whatever device people are using with this particular app will need to be 4.3 or later. Okay. All right, so let's go.
What is it called? Fitbit?
It's called a Fitbit. Yeah, I can show it to you guys. Fitbit, F-I-T-B-I-T. So it looks like this. I didn't order in this color, but it's a it's a similar device. So the app does a lot of stuff. The app actually okay, let me show you. This is the one that I ordered. It's really just a little device. It has It's waterproof, and from what I have heard, this is the best of this this kind of implementation. So you kind of wear it like a watch. You can wear it on your right hand or on your left hand, and all it does is to keep track of your motion all day long. Okay, it doesn't matter where you go. Your Android phone has to be close by because it uses Bluetooth communication to relay all the information collected to your cell phone. But you don't have to wear your cell phone on you as long as it is within Bluetooth communication range, it will still work. The battery on this device is supposed to last an entire week. Okay, so you only have to charge it for, I think, 8 hours every week. You have to kind of take it off and charge it for 8 hours. It can track your activities. The app itself can also keep track of your diet, like what you eat. So if I have the app with me, I will be registering like 2 slices of bread with peanut butter, when I have lunch. So it will keep track of all of that information, your current weight. This particular website actually sells a Wi-Fi enabled scale that can keep track of 8 users. So you just step onto the scale, and then I guess you can either use your app to say, okay, it is me on the scale right now, and it will upload your weight directly to your phone, and then from the phone directly to the cloud application itself. So they will keep track of your weight as long as you get onto the scale and say, okay, I am TAC. So they will keep track of my weight, keep track of my activity, keep track of my sleep pattern. Yep.
I think the Fitbit actually has a local storage on things, so that you don't have to have your phone on constantly. If you don't
Oh, okay.
want to. I think you can sync it like at the end of the day if you wanted to.
Okay, that's nice.
I'm not sure if his own brother has one. It doesn't seem like he always keeps his Bluetooth on, but he has it that he always wears.
Okay, so okay, that makes sense. It has a buffer basically. It can store something internally, but obviously, if it's out of range of Bluetooth communication, you cannot get the live stat anymore on your Bluetooth device. Yeah, it's one of the more successful products of this type. What is the name of the other one? They make headsets, very successful headsets, but not so successful with their fitness, tracking thing. But that's interesting because with app programming, it opens up all kinds of possibilities if you can design, Bluetooth devices, because now your Android device becomes a terminal to control a Bluetooth device. So anyway,
So
you guys.
how does it wake you up silently?
It has a vibrator inside. So it has a motor with an offset weight. So when you wear it, you can set up the alarm to only use the vibrator inside the wristband. So that way only you wake up, because it's not using any sound. And I think it has probably has a gentle wake up cycle. So instead of giving you the full intensity shake to begin with, it will gently start with a small pulse like zzz, zzz, like that, and then just kind of gradually increase the duration of the vibration. I don't know. I mean, I have no idea how it works.
I'd probably alter your dreams a little bit right before you wake up.
Somebody's holding your hand and shaking like that. No, I don't think it goes as far as using the electrical shock to wake you up.
I think I need that.
Probably get sued, in some countries. But it can track your sleep too, because you can wear it, during your sleep time, so it can sense the motion, when you're sleeping, turning around and see whether you're sleeping relatively still or not. So I think it's interesting. It just gives you more information about what you do, or what you do not do during a day.
I think some companies that make the really efficient accelerometers that go in these devices are now being put in phones. And before, people didn't really know what to do with them, but now, since Apple, I think, started putting them in phones,
Yep.
doing IPO.
Yep. And interestingly, accelerometers are called, is it called MIMO? MIMO? They are very tiny mechanical devices. they're finding applications everywhere now. All of these things are quote unquote wearable, even though you have to take it off to recharge it. It's still considered wearable. I'm waiting for the day when they put in like a little offset, gyro generator inside these things. So when you exercise, when you walk around, it would do its own recharging, because of the offset gyro. Yep.
Has the prices for these type of devices come down?
But this is $100, which is not too bad. So I think it has certainly come down quite a bit already. How far will it go? Depends a lot on who's making it and what feature you want on it.
So what do you think is the cost to manufacture something like that?
The
Manufacturing cost?
Manufacturing cost?
Yeah.
Oh, once you get the plastic molding done, and also once you order those electronic parts in large quantities, the actual manufacturing cost is not going to be all that much.
Yeah.
The battery can be one of the most expensive component of these things. It has no user interface. It's 5 LEDs and a motor to turn it. And I would think the least expensive part would be the electronics. Because once you order those things in larger quantities, the electronics becomes a non-factor. The battery can be expensive depending on the capacity. And interestingly, the connector can be expensive too. Anything that is mechanical, tends to be expensive, and you can only lower the cost of those things to a certain point. But as far as the chips are concerned, I don't think that really is the big deal. The ongoing cost of these things is not the hardware. If they sell enough of these things, they can place a larger and larger order each time. The devices will only go down in terms of cost. But the software maintenance cost does not go away as long as the product is still being sold. Okay, so as far as this class is concerned, I think that's good news, because the device itself can be inexpensive. They can be selling a gazillion of these things, okay? But the ongoing cost of software maintenance does not go away at all. You cannot just say, okay, I'm happy with this version here, and I'm going to stop development, because there are competing products. So if the competing products are offering new features, a more spiffy user interface and whatnot, and your app is staying the same, for 2 years or so, you're not going to sell any more hardware devices, even though your hardware device may be superior. So this is a case where the hardware actually helps sell the software, because at a certain point, if you have a pro version, that does certain things that the free version does not do, you may end up with a gazillion people who own these devices and say, oh, no problem, I'll pay $2 to buy the new app, or I'll pay a subscription fee of $5 a year, $10 a year to subscribe to the cloud service. They have these things already. A lot of the diet, exercise, fitness type of programs have a cloud presence. So you're not really just running the app on its own. The app is actually communicating with the cloud service, and they keep track of your progress, give you suggestions and whatnot. And those are all subscription based. $10 a year, $5 a month, you name it, and they price it accordingly. And the device like this is really good for selling the surface itself, which is where money is to be made. The device itself, you can make money out of that, but I would not count on that for too long. Yep. Go ahead.
Side question.
Yep.
What is the native number type in Java?
The native number type.
Yeah, like what is the like you give it a value, and you say integer. Does it and it has to convert? But let's say VB, where it has to convert from double to integer in memory. What is the native counterpart for Java?
Okay, so let me see if I can answer your question. So you're basically saying, if you say, like 1, 2 as a number,
Yeah.
what is the native type of it?
So we're not doing any extra conversions or have it internally
And-
convert one from one type
An
to another.
integer, if you give it just 1, 2, I think the internal type is just regular integer. Now, whether in Java we use 64-bit integers or by default it is 32-bit, that part I do not know.
It's like how math is calculated, then converted into a specific type.
The default type of, I think is the default, which is probably by today is a 64-bit integer.
Okay.
But you can look it up. Look up.
So you can do calculations and have it be formatted as an integer, but in the background it is a certain type.
In the background, all integers are just integers. Okay, so they have long. Okay, I'm confused why Java integer literals default to int instead of long. First, it requires the programmer to adopt a special syntax. So they're only using 32-bit. I do not find a 64-bit reference. Let me see if I can find 64. There are several references, but they're all inside the number itself. Would it make difference if RAM cells were 64-bit? That's useless. For the purposes of the Java programming language memory model, a single write to a non-volatile long or double value is treated as two separate writes. This can result in a situation where the thread sees the first 32-bit. Okay. One of the possible reasons is that int is a default literal. Okay. So they do have long, and the question is how long is a long? How many bits is a long? But int itself is only 32-bit. The reason it has to do with the JVM, the Java virtual machine itself, only can guarantee a atomic write operation of a 32-bit number. If you have a 64-bit number, the write operation is no longer guaranteed atomic, which means if you have a multi-threading program, you can have threads interacting with each other, having basically one thread to write a half of a 64-bit integer, have another thread to cut in, write to the same variable, and then have the original thread to come back in again to finish the writing of the second half of that number. So that's why I think it is, kind of hard-coded that int is always 32-bit, even though by today's standard, 32-bit is not really that big of a number anymore.
What do you mean by atomic?
Atomic write means, it can be performed without getting interrupted. In a multi-threading program, which you can write in Java, C++, or any practical programming language, you have multiple threads executing at the same time. But a thread is not the same as a process. Between processes, which is a process is defined as a program in execution, or basically an instance of a program in execution. Between processes, you cannot share anything. Basically, you cannot share anything. The only person who took the systems programming class is not here. He has a termite in his house, so he has to take an excuse today. But basically, when you have a multi-threading program, each thread can share global variables within the same program, within the same process. So the best way or the most efficient way to communicate between the threads is to use global variables. But the problem of using global variables for communication has to do with certain things you cannot do it in a single write. So that means one single thread, according to the kernel, can say, hey, thread A, it is your turn to execute. Okay, thread A, go execute, do something. And then the kernel can then say, okay, you just ran out of time. Okay, I have to take control away from you and let the next thread execute. The next thread can be coming from the same process, having access to the same global variables. So the other thread will come in and say, okay, I need to change that variable too. Not knowing the first thread is halfway done updating a particular global variable at that time. Yep.
So I was referencing before because what I learned in my VB class is that if you have like a variable that's like the type byte or integer or something small that you wanted to save space as RAM, would actually you're actually performing more calculations, because when you do a calculation, it gets done in
intermediate
double,
form.
then it converts down to that format.
Converting into double first is a really, really, really bad idea.
But it's just how how calculations are done
In VB,
It's
that
natively
really
double.
is that's just a bad idea, because floating point numbers, including doubles, okay, so you can have float, you can have double. They're both what we call floating point numbers using the IEEE floating point number standard. The problem with that representation is some numbers that you think you should be able to represent using like 64 bits is not representable using the floating point format. So that means when you do a calculation, if you go through a few rounds of these conversions, something that should be representable in exact quantities is now off a little bit because of the calculations. So doing all these things in the background is just really a bad idea. I don't think Java does anything like that. If you just write down 1, 2 as a literal number, it is just an int, a 32-bit int. That's basically what it is.
And all calculations are done as ints.
All calculations will be done as an int unless you do your own casting. So if you say in parentheses double and then 12 and then times whatever, then you'll be using the floating point double floating point number calculation. But that's only because you requested it. Okay, if you do not request it, then you say 12 times I, and I by itself is also an integer, then all arithmetics will be done in 32-bit integer arithmetics. There's no implicit or back-end conversion in Java. Just like in C and C++, they do not do a whole lot of those back-end stuff either.
Okay.
Yep. Yeah, but converting to double, floating point numbers in the back end, without letting people know is really just a bad idea.
It just like takes the value, then does it in double, then returns the value as the original type.
Okay. Well, here's another, clarification. It would be possible for a language to require all integer arithmetic but not overflow, if a variable starts with an L or 64-bit. Okay, so that's not really the language feature. Okay. I think I think the conclusion is an int is really just 32-bit.
Okay.
Yep. When Java was first invented in the late 90s or early 2000, 32-bit integers are fine. I mean, it really is an adequate width for integers, and because of the JVM limitations, I don't think they have ever changed that as a default. Right. So back to here, we got everything done. Okay, we have our simple listener adapter. So now we have one-way communication, not two-way. The communication only goes from the model going through the listener adapter, going back to the view. Okay, the other way doesn't work. Okay, we still do not have a way to inject events or triggers into the model, but that's okay. We'll debug the program or write the program one step at a time. This is ready to run. If I just run this program, it's not gonna do anything because it's just gonna go through all the messages. But we'll go ahead and just let it rip, just to see what it's gonna do. Let's save all the changes.
Would you say if you debug the program, what?
Say again?
What did you say?
I said, this program will just, rip because it goes really fast. So there's no way for us to actually see the state change. When you just look at hello world, it's going to get changed to reflect the state changes. But because I did not put any delay between the triggers that I inject into the model, so all of those state changes will occur within a fraction of a second. So as far as we can see, there will be no changes, except we'll see, it gets to the final state, and then that's it. So we'll take a look. We click test, and it says final state. It doesn't say anything in between. It actually did. It's just way too fast for us to see. Okay. There are several ways to kind of remedy this problem. One is to use a breakpoint. Okay, so we can use breakpoints at various points of this program. So we can put one here, put one here, put one here. So I'm setting up 3 breakpoints, and we'll go use the debugger option. So we'll debug as do not switch my view because I don't really need to do that. I'm about to get into initialize. Now this would be a good time to kind of single step into it just to see what happens when we when we call initialize as a method. All right, so we'll step into initialize. Inside initialize, these are the things that we are doing. We reset all the counters. Okay, nothing too mysterious. Kind of launch is configured to open the debug perspective, did not change. Okay, so we want to keep stepping over, step over, and we want to get rid of this breakpoint here. Step over, and now we have notified listener adapter. So we want to kind of keep get into this one too, just to find out what notified listener adapter is going to do. It will check listener adapter is non-null to begin with, and then it will actually do the state call. It will call the state change. So we'll go ahead and step over. And this one we want to step into too, because we want to find out what is the chain of calls that will eventually update the label or the text field on screen. So we want to step into this one, which goes into the simple listener adapter, which has its own call of a state change to a view. So we step into this one, and now we are back into main activity inside its own state change. And now we can go through the switch statement, which is not really surprising. We know exactly what this one is going to do. I'm into a portion where there's no code to. There we go. All right. So now we switch. It's saying no winner. So we get to this point, and if we just step over this and switch back to the emulator, it should. Oh, it's not reflected yet. And we are done with all of these subroutine calls. Getting back to the beginning, initialize is done at this point. And let's see, it's still saying hello world. So the text view, set text is already called to change it to something else, but I'm not seeing any changes.
Maybe it has to be done with its processing before it's visually displayed.
But that means I cannot see any intermediate changes because it's supposed to reflect that change at this point. It's probably because if I lump all of the updates into one single method, it does not do the updates to the actual screen until this. Okay, I think I know what it is. All the changes that I specify in one single event handler is not updated until the event handler returns to the Android system, and then at that point it will perform the updates to the screen. So there's no way for me to display the individual messages here because it is within a single handler of all the click event. It does not seem to make sense, but that's the only explanation that I have about why this is happening the way it is. Okay, so let's switch back to the emulator. It's still not getting updated, so I think that's basically what it is. It can also be an interaction between the debugger in the application, but I don't think that's the case. I mean, doesn't seem to make a, this doesn't make sense to me. But let's go ahead and single step the last one and
Would it be the same on an actual device?
well, on an actual device, you know, I would say it's the same because the emulator is supposed to behave just like an actual device. Okay, so test model is done, and I'm at the end of on click. Let's go back to the emulator. It has not updated yet. Okay. And it's not updated yet. We are now in, you know, a portion of the code that we did not write, that I did not write. So you can see it is, you know, somewhere else within the framework itself. So I think within the framework, it has to get back to a certain point before it updates the screen. Yep. Question?
No,
Oh, okay.
I was just trusting.
Oh, okay. We're in looper loop. Okay, so we are done with the looper loop. Get back to here, and it's updated to final state. So we could not see the intermediate updates at all. It's just, you know, all done in a flash. Any questions about this part? Yep.
In Java, since we don't have pointers, what's best practice to change like lots of values that are like maybe like, you know, maybe objects of certain other types that aren't the same and certain variables of certain classes? Like would I, like if I needed to call a function and I wanted to change like maybe 10 things, like maybe three objects and like a couple of variables, like a couple different classes, like
References.
references?
Yep.
Okay.
Yep. That's basically the only thing that resembles what a pointer can do in C++ is a reference.
So will we like usually have to like set mutator functions and then like call it with that function?
Say again?
So we set like lots of mutator functions, like
Yep.
and then we basically call it from that function in order to do it. Okay.
Yep. You do not expose, you know, as a general practice, you do not expose data members to the external world. So you always have, you know, set methods and get methods to either read the value of something or to change the value of something.
It can get kind of tedious though because you know.
It does get tedious. Yep, it does get tedious, and I think Eclipse offers a shortcut to do it. It can analyze, you know, all your, you know, private data members, and then automatically create the set and get methods. I'm not 100% sure, but I think I might have seen that. Yep. All right. Okay, so we know that the communication on one side, you know, in one direction is working. We just now need to know how do we make the other direction work. So the listener adapter is working. We need the the model adapter to go in the opposite direction. In other words, you know, when the view is getting a click, how do we pass that event or the trigger into the model so that the model can update its state, and then as a result, you know, the whole thing becomes a closed loop at this point. Okay. So that's the next thing we have to do. We already have model here, and RPS model has its own interface, which is iRPS model. So that's good because, you know, now the actual model is already handled. We just need something that we call a model adapter to go from a view, you know, to the model. And we'll first create the interface. We go to new, create a new interface that we'll just call, you know, iModel adapter. And it does not need to have any method, you know, declared, but I already know what I need. So I'm going to say, you know, public void, and it needs to register a particular model. So register model, and in this case it will be an iRPS model M. So, okay, what else do you think a model adapter needs in order to do what it's supposed to? Its only function is as a broker, So when the view is getting a click, getting a swipe, getting some sort of user interaction, the view has to translate that into a method that the model adapter knows. And then that particular method of the model adapter will basically call the underlying model, in this case, of the type IRPS model, to actually do whatever logic that should be triggered in the model itself. So what methods do we have in IRPS model that should be exposed? Let's take a look at IRPS model and find out. We have all of these methods. Most of these methods need to be exposed. So user choose is one, initialize is one, play again is one, back button press is one. So all of those, all of those methods of the interface IRPS model should also be exposed to the model adapter interface. So I'm going to just be a little bit lazy here and copy and paste this. The last one we do not need to copy into the other one. And the new one is called a model adapter. Go. All right. Are there any questions about what the model adapter is doing? It's defining a type so that we can create an actual model adapter class, so that a view has a broker to talk to an actual model representing the business logic of whatever we are implementing. So now that this is done, we can go ahead and make use of this. The first place we make use of this is going to be in the view itself. The view class is main activity. So in main activity, now we need to keep track of a particular member, and we'll call that private I model adapter. Model adapter. And in the initialization of main activity, now we have to create that as well. So I'm going to make some changes to test model, because we are no longer just using test model for the purpose of this program. Well, we can put all of this stuff here and then copy and paste it out, or change the name of this method so it's not test model anymore. We can call it setup model instead. All right, so let's go ahead and do this part. Model. Can't do it yet because I don't have a class corresponding to that interface. I can only do something about it when I have a class already defined to the interface of I model adapter. So let's go ahead and do that. New class, and we'll call the class simple model adapter. And we'll also specify an interface, because we already know it is supposed to implement I model adapter. So we can now just go ahead and specify, we want the interface to be I model adapter. And the nice thing about this is it automatically generates the template for our simple model adapter code. Now this is a class. So the register model part, we'll basically have to remember what model we are dealing with here. In this case, the type of the model is IRPS model, which is an interface. It is not a class. And so the register model call is pretty simple. Model gets M, which is the argument to this particular method. User choose is going to be calling model dot user choose, and we'll give it the same choice. So it really is just relaying all the calls in this case because it is a very simple type of adapter. It doesn't do any translation in between. And play again the same thing. That's it. That's our simple model adapter. We are just relaying, everything over to a model and say, I don't know how to deal with this. The view tells me that this happens. You go ahead and handle it. Okay. So it's just relaying all those information or all those actions to the model and let the model handle all of the actual processing. Are there any questions? Now switching back to the main activity, now that we have a class implementing that, we can now do something about it. Because what we can do now is we can do several things that are actually important. The first thing is we can say model adapter is a simple model adapter. So this will help create the actual object itself. I'm going to have to move this code somewhere else really soon. But at this time, I'm just going to stash it here. Okay, the model adapter is not attached to anything. It is attached from the view to the view is attached to the adapter, but the adapter itself is not actually hooked up to a particular model. So the next thing I'm going to do is to say model adapter register. Is it register model? And let's see if it's smart enough this time to figure out which one is supposed to be the model. Add argument. Yep, you got it right this time. I just like to test the tool itself, just to figure out whether how smart can it get. All right. And once everything is registered, people know exactly who to contact. Everything is done. So this part is done, this part is done, and we can basically get rid of these three. Instead of calling this test model, we'll call it setup model. Now once we change it to setup model, we have to find a place to call it. This would not be a good place to call it because we are not really doing the on click here anymore. So let's get rid of this test model here. And instead, we'll do it in the on create method. We'll set content view, and here we can say setup model. Like that. All right. Well, what I have just done is I have just neutered this program, so now it doesn't do a single thing again. Because nothing is going to trigger anything, even though I have a full setup of the view, the adapter, and the model. There's nothing that is going to happen here. Let's take just take a pause here, take a step back, and see what is set up at this point. I'll probably use next Monday to really completely finish this program with all the buttons in that is necessary. Okay, so on one side we have main activity, ACTI. Okay, main activity is a class name, but it implements iView. Okay, in other words, from the perspective of other objects, this can be seen as an iView object. A reference to an iView can refer to a main activity object. Inside main activity object, it has one thing that goes out. It has model adapter. So model adapter is a private member of main activity, and its only job is to say, who's my broker? If someone clicks on a button, or if I'm shaken and I need to let the model know about something, who's my broker to the model? Okay? So what this does is it links to an object of the type simple model adapter. And this class implements an I model adapter interface. So I model adapter is the interface. This guy in return keeps track of, okay, I'm the broker, so I need to be responsible and know which model actually, handles all the business logic. So on this end here, we have our rock, paper, scissors model as the actual model. But this particular class implements the interface called IRPS model, which is just an interface corresponding to this class. I use interfaces instead of actual classes whenever possible, just so that I do not incur any restrictions to which class can be used as what parameter. Now, how do we go from here, which is a simple model adapter, to over here? Do you guys still remember the private member, the name of the private member in model adapter? Simple model adapter. Okay. It's just model itself. So inside the simple model adapter, there's a private member called model that is a reference to a particular object of the type RPS model. At least that's the way I set up in this application. Are we doing okay so far? Which member of which class is pointing to which object in return? Is that okay? Now, how does it get back? In other words, this model adapter is going to say, okay, RPS model, somebody just clicked, user make a choice, okay? And this is what the user has chosen. So the RPS model would go through its own method to do all the business logic. At some point, it's going to it's going to have a state change. So the state change needs to be notified so that somebody will do something about it, to update the screen, to log an entry, to do whatever that is necessary. So inside RPS model, it has a member called LA. Is it just listener adapter LA? No, I think it's spelled out as listener adapter with a lowercase l. Okay, so this one has listener adapter as a private member, a data member. It points back to not a simple model, but it points back to a simple listener adapter object. Inside a simple listener adapter, there is a view private member that points back to a main activity object. And that basically shows you the links, how a particular object knows how to find the other object. Okay. Are we doing okay so far with this picture here? So now the part that is independent to what application you're doing is when the view gets a trigger or a request by a user to do something like a button click, then what happens is that button click will trigger the model adapter to call the model adapter method. That in return translates to a call to a model method. The model will do its business logic here, do whatever that it needs to update its internal state. If there's anything significant enough to trigger an internal state change, it will basically it has to notify and say, okay, I got a state change here. Somebody needs to know about it. But the way it lets people know about it is not to go directly to the view and say, hey, update this particular text view to something else. The way it does it is to say, okay, who's my broker? My broker is listener adapter. Okay, good. Listener adapter, okay, let me tell you what. I have a state change. Let people know about this state change. So the listener adapter reference will go back to a listener adapter object, and that will keep track of all of the parties that needs to be notified when there's a state change in the state machine in the model. And that in return, the simple, I mean not necessarily simple, but the listener adapter object will update all of its views because it can keep track of more than just one view. You know, it can be multiple views. And then for each view, it will call the necessary method of that view and say, okay, you know, there's a state change, you know, do whatever you need in order to reflect that change. Some of the views can be corresponding to a log file or some kind of logging ability, and in those cases, you know, they just need to add one entry to a list or to a text file. To other views, you know, you may be updating something on the screen, and some other views can correspond to adding an entry, you know, that is cloud-based. So it doesn't matter. It can be sending something to a Bluetooth device also. But basically, this is the entire cycle or the life cycle of a particular trigger. The trigger starts with a view. It goes to an adapter, goes into the model. The model does what it needs to do, comes up with a state change. The state change goes to a listener adapter. The listener adapter will update all of the views. Okay, so let me ask you one question. Do these two objects have to be exactly the same? In other words, the view object that initiates all the entire chain of events, does it have to be exactly the same object that will get the result back? Is there a requirement that it has to be the same? Nope, there's no requirement whatsoever. Now, with something that we have already talked about in today's class, can someone give me an example of a quote-unquote view object that can cause something to happen like that, except it is not the one getting anything back? It is something that the view object generating the event is not the view object that gets any type of update as a result of the model doing its job. Yep. Okay, Fitbit. Okay, so in the case of a Fitbit, what happens is this object is the Fitbit object. That's your wristband. Okay, so the wristband is going to say, okay, you know, I have just, you know, accumulated a log of, you know, this many entries. Oh, great, you know, the Android device is within range. I can now talk to you. So it would go to the model adapter. In this case, the model adapter, you know, nothing says, you know, that wristband can only talk to one single Android device. Okay, so if it has the ability to register to multiple Android devices, it can basically scan all the time and say, okay, can I connect to at least one of the Android devices? Okay, because you might have one, you know, on the scale, you might have one on an exercise bike, you know, so that, you know, multiple devices can be listening to the same wristband. But one of those things can be your Android device. So it goes into Android device here. The Android device can do whatever the model requires it to do. The model can also, this can be on the internet as well. In other words, one of the model adapters can say, you know what, you know, I need to send this information to a remote website, to the Fitbit, you know, homepage, so that, you know, the cloud surface will be able to do the processing, will be actually implementing the model. So the model will do whatever it needs to do, okay? And when the model is done, it is going to say, okay, you know, we have some state change, you know, because of this. Let's just say that, you know, the Fitbit is saying, okay, I think Tech is awake now. Okay, you know, he just woke up in the morning. Okay, it's a state change. So that state change will go back to the listener adapter, and the listener adapter will say, okay, let me figure out, you know, who needs to be notified about this state change. All right? Well, there can be many things, like my own Android device can be a listener and say, okay, you know, I need to know that Tag is awake, so I can now display, you know, what he needs to do today. I will give him a little agenda for the day. Okay, at 8 p.m. you need to do this. Remember to bring this to school. Blah 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 blah. Okay, I can also have subscribers, right? You know, people who are, you know, who wants to track my activities. So it will say, okay, Tag is now awake. You can call him now, whatever. But that's the job of the listener adapter, is to figure out who needs to know about tech being awake. The wristband itself is not one of the listeners. Is that okay? Is that analogy making any sense? So that means the logic of the adapter can be complicated. It doesn't have to be as simple as what we talk about in this class. Because if the model is not local to the device itself, it is web-based or cloud-based, then the listener adapter, or the model adapter now has to handle the network connectivity issues, send the messages over, make sure all the checksum works out, and so on and so forth, authentication and everything else. It's not as simple as, oh, here's the object to handle it. Yep.
So on the simple model adapter, you name that because it's updating the model. So
Also because the model is on the same device in the same application program.
So then going back to view, you call it simple listener adapter, but aren't both of those adapters listening? Going from view to model and model to view, aren't they both listening? Couldn't they both be a simple listener adapter? I'm just curious why you named them like that.
These are all seen from the perspective of the model. The model, I see what you mean. You think
Couldn't that be simple?
the model is listening to the view, right? And then the view is listening to the model. Is that how you're interpreting it? I suppose you can look at it that way. So in that case, it would be probably better to call this a view adapter instead of a listener adapter. But in certain cases, the view and the model can be the same thing as well, which kind of makes it a little bit more difficult to separate the two. But the whole idea is to have a particular object or a class to handle the logic of handling. Okay, I get something here. I get a request. Who is going to handle the business logic? Not me, but I might know someone who can do it. Right? Any questions? When I first came to school today, I just kind of, I knew that I wanted to talk about the Fitbit, just because it is kind of a cool device and I'm getting it and I can, give it a whirl and see, how well it works. But I did not really quite make the connection to the model view adapter, and now approach that we are talking about. So as I talk about this, and I think about the Fitbit, I go like, hey, this is a perfect example because, it originates, the trigger, it goes through the logic, and the adapter may not even want to update the Android device itself. It might want to go, to the internet to update, something that is remote. So, it just kind of works out that way. Yep.
Does it have a good Linux support? I don't know how it syncs, but does it have to be 4.0 Bluetooth, or will it work with
It's 4.3 or later.
Oh, okay.
Yeah. If you look at the Fitbit website, they actually specify that. So I can look it up real fast. Fitbit, Flex, Android 4.3.
That's the only syncing method, because I had like a really older Android phone, so.
Oh, okay. Yeah, I think that's its explanation. Several Android devices are supported at this time. It needs the Bluetooth Low Energy Radio present in some devices as a part of Bluetooth 4.0. And that's the reason. It gives you a list of these particular devices. I have a Galaxy Blaze, which is not listed here, but the Blaze came out between S3 and S4. So I would assume that it has the same chipset as a hardware. It only makes sense that way because Samsung is a huge manufacturer. It's not going to say, well, I will test this part out with the Blaze. No, it's going to say, what is in stock right now? Well, I still have a whole gazillion of these Bluetooth drivers. Let's use up all that stock. So I would assume the Blaze also has the low low energy Bluetooth device. But that's the reason why it requires 4.3 plus devices and won't work with earlier devices. Any questions? So how do you know a particular device whether it has this feature or not?
Google your phone.
You can Google your phone, but sometimes it does not disclose that information. The problem with some of these devices, Samsung, Galaxy, Blaze, 4G, that's the device that I'm using. So if I just try to look up
Go ahead and specs.
Bluetooth low energy, it usually does not show anything. Well, this particular device is also bad because it is a T-Mobile device. So it's only sold, through T-Mobile. And if T-Mobile decides, it's not important for people to know about that particular aspect of the device, they don't need to release the specifications. So I can look for specifications and see if I can find anything that's useful.
It's 3.0.
Is it 3.0? Oh, okay. So it won't work with my device either. Oh. It might work with a Bluetooth adapter to a PC, so that would be the only way to sync it.
Yeah.
Yep.
Yeah, there's probably no Linux support. It's probably I had like Windows specifically do it, which is
Could you have like a Bluetooth adapter where it's just Bluetooth 3.0, then it converts to a 4.0, this type of signal, or it doesn't need a specific type of profile for it to work?
I don't know. I think it's just using that one aspect of 4.0. Well, I guess we'll find out. When I get the device, when I get the wristband, I'll try to see what device will work with it at home.
So you gotta sleep next to your computer.
With my with my computer, hooked up, and powered up the whole time, right? The fan blowing warm air on my face. No wonder I'm not sleeping well. Well, we'll find out. That's gonna be interesting. It gives me an excuse to upgrade my phone too.
it'd be a fun open source project to have a Bluetooth support for syncing on Linux.
Yep, that would be interesting. Actually, if you go back to the Fitbit website, let's go back to.
I wonder if you get like a raw data dump, like just try to like parse through it, the data that is actually stored on there.
That's interesting. Maybe there's a way to do it. I think the Bluetooth requirement is the same for all of the devices. Okay, Araya is the smart scale. Okay, that's just a scale. And I thought they make a particular device, that does all the syncing. Independent device that does all the syncing. Let's take a look here.
Why would you want that? Just so that it doesn't matter what platform.
Right,
dependent.
just in case your phone cannot do it. Charging cable, wristband, wireless sync dongle, plugs into USB port to sync your Flex One and Zip tracker to your online account. So that's basically what I need.
What about a Bluetooth adapter for a OTG cable?
Charging cable, sleep band, base station, plugs into USB to charge your ultra wireless activity tracker. So I think this is what, this is the device that makes it possible. So you don't even need to own a portable device. Plugs into USB port to sync your Flex One and Zip trackers to your online account. So I won't be able to track it. I cannot see anything on my Android device, but when I sync it, when I get home, I will still be able to accomplish the same thing.
But I think with your wireless, with your Bluetooth on your computer, you'll be able to sync it. It's just a communication side.
Yeah, this one is a wireless sync, so it should be able to do it.
Yeah, I mean, what I mean, I think that's assuming that you don't have either Bluetooth or Wi-Fi or like the computer. You can use your Bluetooth from your laptop. I think
Yeah.
you won't need that.
Oh, you think this is just a Bluetooth to
Yeah,
USB
if you go on eBay,
dongle?
there's tons of them you can buy for $2 or $3.
Yeah. I actually have quite a few in my lunchbox already.
You probably still need a client though.
Hmm?
You probably still need a Windows or Mac client in order to have it sync well.
Yeah, you mean the software?
Yeah.
And then this one is really just a charger. It's also a wireless activity tracker. So this one is doubling it's doing both at the same time. But it only shows one device here. Oh, okay. It only works for the Ultra, not the Flex. This one works for all of the other devices, but it doesn't do any type of charging. It is only doing the sync. So it might be just a USB to Bluetooth converter, which you can buy for like $2,
Yeah.
right? So now the question is whether the software will run in Linux. You know what? That part does not bother me at all anymore,
Really?
because I can run. Well, I run QEMU and I pass through USB devices directly into the virtual machine. So if it runs in Windows, I just have to run Windows inside the virtual machine and pass that device through to my Windows virtual machine, and everything will still be okay. That's going to be interesting. How they're going to sell this device, because if they have a hardware requirement of really kind of recent type of Bluetooth devices, they're going to lose out on a lot of the market.
It makes sense though. I mean, to not support lower Bluetooth just because we just speed up batteries.
Right, but you can also change the software itself so it doesn't try to sync all the time. So when you move on to a device that cannot implement the low power feature, you can change the software so that instead of doing a sync every 5 seconds, you can say, okay, this is a device that does not support low power Bluetooth, so you would not attempt to make that connection every 5 seconds. Instead, every 5 hours, every 4 hours, it will do a sync. So you won't be reading anything real time, but it will still be on your device at least.
Will the Bluetooth within the Fitbit be able to support backwards compatibility? With the hardware you can be able to read the
I think it would.
Oh, okay.
Yeah.
So it's just all software then?
I think the requirement is only on the Android device, so you don't drain the battery of the Android
yeah,
device.
that seems like an easy fix then.
Yeah.
They're just too lazy to do it, I guess.
Maybe maybe the software will still run. It just won't. That feature will not work. You just lack the real-time display ability.
Have you tried to load the application on your device?
That's a good idea.
If it just like, oh, do not see a supported device.
Well, it definitely won't see it. But the question is, it will even install. And if it does install, it should come back and say, the Bluetooth ability of this phone is not
Yeah.
up to the standard.
Because I think the only requirement for the installation is that the necessary